Hey guys, welcome. In this video we're going to be talking about the applications of systems. So we've learned about the different types of ways we can solve a linear system. I'm going to read this real quick. I want you to write down all of this right here, the essential understanding, and the concept box right here. So anyways, it says you can solve a system of linear equations using a graph, substitution, or elimination method. We've looked at each of these. The best method to use depends on the form of the given equation and how precise the solution should be. Okay, so graphing, if we want to visualize, we can estimate a solution. Graphing is usually better for estimation. Substitution, when one variable is already solved for, so if y equals x plus 2, we know what y equals already. Substitution would be best. And elimination, when the coefficients of one variable are the same or opposites and they're lined up, then we can go ahead and use that method. Let's go ahead and take a look at a few examples. Okay, so here's our first example. Go ahead and write this all the way out. It says fashion designer makes and sells hats. The material for each hat costs $5.50. The hat sells for $12.50. And the designer spends $1,400 on advertising. How many hats must the designer sell to break even? So the concept break even means what she put in. How many does she need to sell so she has not made any money but she hasn't lost any money? So anything above that number of hats would turn a profit. Anything below that would turn to be a loss. So we need to look at two things. We need to look at how much is she making, so income, and how much is the income from the hat sales. We should do hat sales. Let's do that. That might make a little bit more sense. Okay, so we're going to do hat sales, or hat cost, that's what I'm talking about, versus hat sales. Okay, so we could do y equals, so the cost of a hat is going to be equal to, well, it costs $5.50 per one hat. So we'll do H for hat. We could do X as well. And that's going to be also added on to that. She spent one time $1,400. So the hat costs $5.50 per hat, plus she had a fee for advertising. Versus the hat sales, for her hat sales is going to equal $12.50, right, for each hat that she sells. Okay, so using this equation, we should be able to come up with a way to figure out where is the break-even point of these two. Now, the good news is both these equations are already solved for y in the way that we set them up, so we can actually just substitute them in for each other. And remember, y equals y, so instead of this y right here, I'm going to replace this y with this piece. So we're going to get 1250 H equals 550 H plus 1400. Okay? So I'm going to go ahead and get the H's all together. So I'm going to actually subtract 5.5, or $5.50 H from one side. That's going to cancel. And subtract from this side. And that's going to go ahead and we're going to subtract that. I believe that's going to turn out to be 7. Always double check with your calculator so you don't make a mistake. But I think I should be on the money, and I am. So it becomes 7H equals 1400. And divide by 7, it should be 200, I believe. Again, let's always double check. And I did not mean to say 200. Let's see. I divided by the wrong number in my calculator, and it is 200. So the break-even point is going to be selling 200 hats. Now, it didn't ask me how much money that would be, but I could easily find that 200 times 1250, which would be a sales of $2,500. But that would be my break-even. Let's go ahead and look at another example. Okay, here's an example where, this is example 2, where we're talking about two different things. We're trying to figure out when are they going to have the same amount of something. So it's very similar to a break-even. Again, the whole point of a system of equation is to figure out where two lines meet. So that's kind of why you have a lot of these kind of examples. So local zoo is filling 2 water tanks for the elephant exhibit. One water tank holds 50 gallons and is filled at a constant rate of 10 gallons per hour. The second contains 29 gallons of water and is filled at a constant rate of 30 gallons an hour. When will the 2 tanks have the same amount of water? So we're going to have tank 1 and an equation for that. And we're going to have tank 2. And I'm going to use some variables. Per hour, so hour is going to be kind of a good indicator because the question is when will the 2, and probably how much they contain. Okay, so one water contains 50, and so one's going a little bit faster. The second one is 29 gallons, a little bit slower, so amount. Okay. All right, so next we want to set up an equation. Okay, so the variables we're going to use for this, sorry, I didn't use that, H and A. Okay, so the amount that tank 1 has, well, it already has 50 gallons, we know that, and then it's going to add 10 gallons an hour, right? And tank 2 already has 29 gallons, and we're going to add 3 gallons every hour. So when will the 2 tanks have the same amount of water? Let's go ahead and find that out. Okay, so we can go ahead and solve this. So we need to set up a system of equations and solve. Okay, so let's see here. Here we go. Notice they both are equal to A, so we can actually set them equal to each other. We could also use subtraction property and elimination. You see how the A's are lined up and they're the same? So let's use that this time. And if I subtract, we should get it. So A minus A, that goes 0. That's why we call it elimination. 50 minus 29 is going to be 21. And 10 minus 3 is 7. H. We're going to have to subtract the 21 over here. And we get negative 21 equals 7H. And then we're going to divide both sides by 7. And negative 3 equals H. So what does that mean? When will the 2 tanks have the same amount of water? This is kind of an interesting one because the one with more water is filling up faster than the one with less water. So if we continue to go on in the future, that won't happen. But if we were able to go in the past, we would actually hit where they would meet at the same, and that would be at negative 3 hours where they'd have the same amount. So if I went 3 hours back in time, they would actually have the same amount. Okay, so the big thing we're going to focus on is trying to set up these equations from and then solve using our methods of substitution, elimination, or probably our primary ones. All right, guys.